Good evening, class. We are looking at chapter 3, differentiation rules. The section 1 is about derivatives of polynomials and exponential functions. So we are covering derivatives of polynomial and exponential functions, the product and quotient rules, trigonometric functions, the chain rule, implicit differentiation, derivatives of the log function, rates of change, exponential growth and decay, related rates, linear approximation and differentials, hyperbolic functions. So we looked at the derivatives and rates of change, the average rate of change of y with respect to x, the instantaneous rate of change of y with respect to x. We looked at the definition of that f prime of a, and then also a general format which is known as the differentiation function, f prime of x, that is defined as the limit of f of x f of x plus h minus f of x over h as h approaches you. Okay. Now we want to look at the derivatives of polynomials and exponential functions. The very first thing I want to look at the horizontal line, y equals c, a constant. If you have a constant, y equals any number, 5, 10, negative 8, its derivative is 0 because the slope of any horizontal line is 0. That's one way to look at that. Okay. So any constant, the slope is 0. So if f of x is a number, f prime is 0. If you go by this definition and y or f of x is c, let's plug in and see what happens. I hope you realize when f of x is c, f of x plus h is the same as c or anything else because it is an independent of x. And therefore the numerator is 0. And this is equal to 0. It is important to know h is not 0. H is approaching 0. So 0 over any number, as long as we know it is a number, it is considered to be 0. So the derivative of a constant becomes 0. This we were discussed in algebra, the compound interest, a equals p times 1 plus r over n to the power of nt. We went through the process and we showed if we go through the process, we end up with a being p e to the power of rt if we compounded continuously. Remember, is a is the amount, p is the principal, r is the rate, and n is the number of compounding. So if we keep on going, that's what we get. In other words, it gives rise to the definition of e, which is 1 plus 1 over m to the power of m if we take a limit and we let m go to infinity. Needless to say, e is not missing. E is just like pi. It's an irrational number. It's a very important number. And that's why it's been given a name, okay, as e, and it is equal to 2.71828. That's one definition. We've seen it in algebra. And this is another definition, okay, in calculus. Okay, the limit of 1 plus 1 over n to the power of n as n approaches infinity, or the limit of e to the power of h minus 1 over h as h approaches 0 equals 1. So both of them, and this one we had it in algebra, this one we have it in calculus, and we will look at it here later on class, okay? We will look at the proof in a moment. So there are some differentiation formulas that I want to quickly go over, and we will look at some of the proofs. For example, the derivative of a constant is 0. The derivative of x is 1. Okay, if it's kx, becomes simply k, if it's a number in front of that. This is a very important formula, the power rule. X to the power of n gives you n, x to the power of n minus 1. The constant multiple, you just keep it. Okay, so if it's differentiation, just differentiate f of x and then keep the c. If you're differentiating piece by piece, differentiate them. So the derivative of f plus g is f prime plus g prime, the same thing for the difference. And there are some formulas here. It's coming up, and we will look at some of the proofs in a moment, class. Okay, so the constant, the power rule, the exponential rule, and these are trigonometric functions, which we will look at shortly. So I want to quickly, we did look at this one. I want to quickly look at the power rule class. And so we are going to use the definition to get there. Okay. So what is f of x plus h? All right. Where f of x is x to the power of n. So you're going to put x plus h to the power of n minus x to the power of n over h. And you take a limit as h approaches 0. Now, how do you work it out? I hope you remember the binomial, theorem. Okay, when you want to expand this, okay, what happens? Okay, so here's the expansion. Okay, I hope you remember the expansion was as follows, everybody. The expansion of this was Cn0 x to the power of n plus Cn1 x to the power of n minus 1 h plus all the way to the end, which is Cnn, x goes away, and h to the power. That was the extension, the expansion of that, and this is exactly what we have. Now, what was C? C is the combination Cnr was n factorial over r this is r factorial times n minus r factorial. Okay, class? Now what happens is this. Cn0 class, Cn0 ends up being 1, Cnn ends up being n, Cn1, my apologies, 1. Okay, this is 1 class. This ends up being 1. So Cn0, let me write it here, Cn0 equals Cnn equals 1. Okay, and then Cn1, it's equal to n. All you have to do, apply this formula. Okay, so those are the ones that are important. The rest becomes very straightforward, and how we get rid of it, you see it in a moment. So therefore, when you expand it, everything involves h. This one doesn't have an h, class. This one doesn't have an h, okay? And this one cancels out this one, okay? So take a look. This one cancels out this one, okay? The rest remain. The rest remain. So again, the first one goes up. Now, all of them have h. So if we factor out the h, let's see what happens. Okay. You can factor out the h and this and cancel this h. This one won't have a h, but this one has h squared. This will have 1. All of them will have some, and the last one will have h to the power of n minus 1. So take a look at what happens. If you factor out the h from the top, the first one has only one h, cancels out this one, but the rest of them have more than one. And so what happens? H is approaching 0. Every piece goes to 0 that involves h except the first one. And believe it or not, this is the proof class. Okay. I won't ask you the proof, obviously, but if you can follow it, you are in good shape. Okay. I won't ask you for the proof, but it's good. Let's look at another proof, and that is the sum rule. What happens if we have f plus g, and we want to differentiate that? It's f prime plus g prime, meaning just doing piece by piece, okay? How does it work? We are going to prove it using the definition. First, let's say capital F of x is lowercase f plus g. Let's define it that way. So this formula uses capital F, everybody. This formula uses capital F. And now let's replace the capital F with this. So this becomes f of x plus h plus g of x plus h minus, and this becomes just f of x plus f of g. Again, each one is in brackets over h. Okay. Now, everything is over h. All we have to do, we just reroute things. How? We put, this is minus f of x. Let me just write this. This is, everybody, minus f of x. And this is minus g of x. So what we are going to do, we are going to put minus f of x next to this, minus g of x next to this. Take a look. We just rewrite it as such. We make up two fractions. And then we applied the limit law, the limit of the first plus the limit of the second. Okay, the limit of the first plus the limit of the second. And therefore, what is this? By definition is f prime. What is this? By definition is the g prime. Believe it or not, this is the proof, everybody. This is the proof. It's very straightforward, everybody. Okay. Let's look at these examples, and I have put the formulas for you here, be the constant and the power. Very simple, okay? So just pay attention to the independent variable, which is x. So the exponent sits in front, and then you subtract 1 from the exponent. So 6x to the power of 6 minus 1, or 6x to the power of 5. Some students may already know that, but let's just cover it for everybody. Part B, 1000 sits in front, and x to the power of 1000 minus 1, okay? This one is, remember, the independent variable is t, so we keep it intact. 4 sits in front, t to the power of now 4 minus 1. Okay, so you want to pay attention to your independent variable. This one, r is your independent variable. You can say y prime, you can say dy dr, okay? Now 3 remains, then r squared becomes 2r times 3, which is 6r. I have put different notations on purpose. Y prime, dy dr, this is in Leibniz notation. Leibniz notation, okay? Remember, Newton and Leibniz are given credit for invention of calculus. Although calculus has been in the making for over 2,000 years, but because they found the relationship between integration and differentiation. In any event, so this is a notation, dy dr, to tell us the independent variable is r, or there's another one, 6r. Part E, 10 times, now this becomes 6x to the power of 5, or 60x to the power of 5. I'm assuming everybody's following that, okay? It's very straightforward. Let me just write that in case. So this would be really 10, okay, times 6x to the power of 5. This would be 3 times 2r. Remember, r to the power of 2 minus 1. Okay. All right. How about this one? We are going to look at each term separately. So the first one, 8x to the power of 7. The second one, plus 12 times 5x to the power of 4. 12 and 5, the product is 60. Minus 4 times 4x cubed, so minus 16x cubed, plus 10 times 3x squared, 30x squared, minus 6 plus 0. And of course, we don't have to write the 0. Why is it 0? Because it is a constant, everybody. It is a constant. Okay. I hope you remember. We did all of this in the previous section, and I'm doing it on purpose. Obviously, I'm going to show you the easy way out. Okay, so this one, simply put, is 5. There's really not much you have to do. Okay, what happens with this guy, just the way it is, it can't be done. We use an algebraic technique and we rewrite it as 2x to the power of minus 1. Now we can write 2 times negative 1 x to the power of negative 2. Okay, so let me just write that for you first, just to be on the safe side. So it becomes 2 times negative 1 x to the power of minus 1 minus 1, okay, or minus 2. And then you rewrite it, okay? I want to make sure that we can handle it. Notice the first step is algebra, and then it's calculus, and then it's back to algebra. So algebra, okay? I mean this part, algebra, calculus, back to algebra. This one is simply 7 times 2x or 14x. How about this guy? We change square root of x to x to the power of 1/2, so we can use the power rule. X times that is x to the power of 3/2. Okay. So how do we differentiate this? 3/2 sits in front. We subtract 1 from it. So 3/2 x to the power of 1/2 plus 5. Okay. 3/2 sits in front, and the exponent goes down by 1. Now, the reason I'm going to rewrite it like that is because it was given in the form of square root of x here. Okay, class? Because it was given in that form. Otherwise, it's really not that big of a deal. Okay. All right. How about this one? What's the answer? I hope you realize this is a number. So the answer is 0, meaning it's just pi squared or 10 squared or e squared or 700. It is a constant. The derivative is 0. It is a number. The derivative is 0. All right. All of this, we can use the power rule, but we have to rewrite it first using our algebraic techniques. So for example, the first one is x to the power of -5 before we can use our algebraic techniques. Okay. And now it's -5 x to the power of -6. Let me write that. So now f prime becomes -5 x to the power of, subtract 1 from -5 becomes -6, and this is your answer. Okay, everyone? I want to do part B, and I want to use the power rule, so I'm going to rewrite it first. I hope nobody has any problem with the algebra. And so now f prime becomes 2/7 times -3 x to the power of, now subtract 1 from -3 x to the power of -4. I'm done with algebra. I rewrite it, and here's my algebraic step again. So let's quickly recap, everybody. Algebra, calculus, algebra. A lot of algebraic techniques involved, so you really can't afford to be uncomfortable with that. All right. So what happens next? The same thing. You write your algebraic techniques first, okay, so that you can use the power rule. So f prime is 2/9, okay, times -4 x to the power of -5, and you just rewrite it as -8/9 x to the power of -5 goes down, becomes to the power of +5. Okay. All right, let's look at a few more examples. Again, the way they are given, we cannot use the power rule, but we can use the power rule by being very careful, noticing what needs to be done. Obviously, the first one is very straightforward. You rewrite it as x to the power of 1/2. We've done this, okay? And so f prime is 1/2 x to the power of, now subtract 1 from 1/2, you get -1/2. So 1/2 x to the power of -1/2, okay, which becomes 1/2 square root of x. Rewriting it results in 1/2 square root of x. So I hope you see we have algebra, calculus, algebraic. All right. Let's write part E first. And then we want to find f prime, so we are going to go with f prime is 2 times 4/5 x to the power of now 4/5 minus 1, okay, becomes minus 1/5. So you have 8 over 5, okay, and then the denominator also has x to the power of positive 1/5, x to the power of positive 1/5, and that's the fifth root of x. So algebra, calculus, algebra, algebra, okay, there's a lot of algebra involved. What about part F? It's important that we are going to discuss the quotient rule later on, but you don't need the quotient rule when you have just one term in the denominator. Divide this one and then divide this one first. So rewrite it as 10 minus 7x. The answer becomes negative 7. If you don't see the easy way out, you may have a hard time finding it through the long way. So make sure you're comfortable with that. We're going to move on, everybody. All right. We want to find the equation of a tangent line, and now we need a pair, okay, and we need the slope. The pair is you basically plug in 4 and you find the pair, which is 4 squared 16 minus 3 times 4, 12, and minus 1 becomes 4, 3. What about the slope? Find f prime of x, plug in. So f prime of x is 2x minus 3. And therefore, if I plug in 4, I get 2 times 4 minus 3, or 5. I have the slope. I have a pair. And y minus y1 is m times x minus x sub 1. So I wouldn't worry about that. It's easy. The difference between this section and previous sections, it's a lot faster, okay? Because I'm taking the easy way out. I'm using the differentiation formulas. Find the point or points for which the tangent lines are horizontal. Well, what does it mean? If we have a horizontal tangent line or any horizontal line, the slope is 0. So all you have to do, find f prime and then set it equal to 0. So here's f prime, 3x squared minus 6x. Because it says horizontal, set it equal to 0. So because of this, okay, we set it equal to 0. And we factor out the 3x. X becomes either 0 or 2. It's important to know that there are two pairs. X is either 0, you have to put it back in, gives you 0, 5, or 2. And if you plug in 2 cubed minus 3 times 2 squared plus 5, so this gives you 0, this gives you 2, and then this comes from the original function. I can't emphasize this enough, class. So 0, you put it in here, and it gives you 5. 2, you put it in here, and it gives you 1. So there are 2 points where tangent line is horizontal. All right, for the exponential function, normally I go over that myself, but to save time, let me just quickly explain it to you right here. I'm assuming everybody can follow this. So you write f prime of x as such, okay? Now the idea is that we want to calculate the derivative of the exponential function in general, f of x equals a to the power of x. What is it that we are looking for? I want to make sure that everybody understands what we are looking for. Let's calculate the derivative of a to the power of x, and then we'll see what we are looking for. If we calculate it using the definition, this becomes a to the power of x plus h minus a to the power of x h. This we can factor a to the power of x. Okay, and because the limit applies to h, okay, we can take it out. So take a look at this one. Okay. So we have from here, we go here, we go here, we go here, and then we take the x out. So I want you to pay attention to what I want to go over. So we get here, and I am going to compare these two. The idea is what? The idea is, what if there is a number? What if there is a number that this piece becomes 1? If that number exists, everybody, then f prime of x becomes a to the power of x. That means a function and its derivative are identical. Is there such number? Okay, so I want you to pay attention to this. Never mind the rest, okay? Never mind the rest. So we came up with the derivative and we want to compare it to the original function. So what they do the numerical analysis, okay? And so they deal with number 2 and number 3. So if you go with number 2 and you let h go to 0, notice what's happening. They end up with about 0.7 here. For number 3, they end up with like 1.1. I hope you are following what I'm saying. So what they notice is we don't have that number, but there is a number in between 2 and 3 such that this limit goes to 1. And that one, they find it with the numerical analysis and they give it a name E. Okay, so there is such number and they give it a number, they give it a name E. And therefore, they come up with the idea, okay, you can read all of this on your own. And the idea is this: if f of x is e to the power of x, f prime of x equals to f of x, or the derivative of e to the power of x is itself. That's what we are concerned with. And we actually prove this limit, okay? Went over the proof of that limit. I hope everybody is comfortable with that, okay? So let's look at a couple more examples here. If f of x is e to the power of x minus x, we want to find f prime and f double prime. Okay. To do that, what is the so f prime of x? What is the derivative of e to the power of x? Is itself minus the derivative of x is 1. So you get e to the power of x minus 1. If you differentiate it again, you get e to the power of x minus 1 gives you 0. So simply e to the power of x. So the first derivative is e to the power of x minus 1. The second derivative becomes e to the power of x. And believe it or not, if you happen to continue, you end up with the same result, e to the power of x. Now, the next question, I've picked this question on purpose because the independent variable doesn't have to be the good old x, okay? Or for that matter, it doesn't have to be, you know, t or even theta. Normally, those are the case. But if you come across something else, in this case, r, you can literally take the r and change it to x if it's confusing for any. So if it is x, you have e to the power of x. I want you to see this. Assuming this is x, this is e to the power of x, okay? And this is x to the power of e, okay? But r is the independent variable. So the derivative of e to the power of x is e to the power of x. The derivative of e to the power of r is itself e to the power of r. But this is x to the power of e. So the derivative would be x to the power of e minus 1. In this case would be, and e sits in front, e x to the power of e minus 1 or e r to the power of e minus 1. Okay? So again, imagine it's x, so it becomes e to the power of x. And this one becomes e sits in front, x to the power of e minus 1. And again, if you have for any reason you have a difficulty with this, change the r to x and then bring it back. Change the r to x and bring it back. Okay? All right. We want to show that this curve has no tangent line such that the slope is 2. Well, first, let's find, remember, in order to come up with the slope of a tangent line, we have to find f prime of x first and then deal with that. So let's find f prime of x and observe what happens. We take it from there. The very first step is to take the derivative of the function. f prime of x is 2 e to the power of x plus 3, okay, plus 5 times 3x squared or 15x squared, okay? And what happens is that this is always larger than, okay, 3. Why is that? Okay, that's why, okay, if we can show that it's larger than 3, there is no tangent line with slope 2. Well, this piece, 2e to the power of x, I hope you remember the range for basic e to the power of x or a to the power of x where a is larger than 1, it's 0 to infinity. So this is always positive. It's always positive. What about this one? Also positive. Why is that? Because of x squared. Therefore, this expression will always be larger than number 3. And that, therefore, tells us that we can't have a slope of a tangent line to be equal to 2. I hope everybody is okay with that. Okay, class. So that should take care of the business. All right, let's go with the next example. Okay, let's go with the next example. This was, I hope, pretty straightforward. We want to find the distance, again, from 2 to 4. This is the good old algebra problem, okay? So we don't want to dwell on that too much. Plug in 4 and 2, do the math. In fact, we did either this question or something similar to that. And when we come up with the answer is 7 meters per second. So I wouldn't worry about that. Now, what is the instantaneous velocity? That means differentiate, everybody. And so we are going to differentiate that. That becomes the velocity, okay? And we want it after 4 seconds, we just plug in number 4. The units are the same. The units are the same for both cases, everybody. Okay, so 11 meters per second, and we're done. Now, what about acceleration? We've already discussed that this is the second derivative, right, class? So if I take the derivative again, I end up with 4. And it so happened that it is independent of t. So if it had a t, I would have to plug in 4, but it doesn't have. That means it's always constant 4. And why is this meters per square second? Because of this. Let me just write this for you. So a of t is dv dt, okay, class? So that means the units of velocity over the units of time. The units of velocity is meters per second, and then units of time is seconds. So meters per second gives you meters per square second. Now, the last part of this question says, when does the object reach a velocity of 31? Well, here's the velocity, class. Set it equal to 31, and you're done. Solve that. So in other words, that's a simple algebra. Move the negative 5 becomes positive 5, 31 becomes 36, divide by 4. So after 9 seconds. After 9 seconds. So again, a quick recap. This is basic algebra. The instantaneous velocity is the first derivative. The acceleration is the second derivative of the position or distance function. That's really the point of this question, okay? Here's the last question. This equation is called a differential equation. A differential equation has a specific definition because it involves an unknown function and its derivative. I hope you remember the definition of various equations. For example, an absolute value equation involves an absolute value, okay? A radical equation, a rational equation, a linear equation. So a differential equation is the one that involves the derivative of the function. So if the equation is given as y double prime plus y prime minus 2y equals x squared, okay? We want to find A and B and C such that y equals ax squared plus bx plus c will do the job. Okay, so how do we pursue, how do we do this? It's very simple, class. You look at the question and you look at your equation and you say, okay, now we know y double prime plus y prime minus 2y is x squared. So, and this is y. Okay, so I need to find y prime and I need to find y double prime. Okay, so let's do that. What is y prime? Y prime is simply 2ax plus b, and then what is y double prime is 2a. So the very first thing, find those, and the next thing, now put it into this equation. When I put it into this equation, I get this. How do we solve that? In essence, you have a, b, c missing. You have the linear equation for 3 variables. It's a system of equations. How come it's a system of equations? All you have to do, look at the left side and the right side. The left side is a quadratic function. The right side is a quadratic function. So we are going to write each one in descending order, and we are going to mix and match their coefficients. So if you look at the left side, okay, we are going to write it as such. We are going to put together the following. They both have x. We're going to put together the following. They all have just a constant. And I'm going to write this in descending order. So that means the first thing would be minus 2ax squared. And then the second one, I have these two in red. The two in red would be 2a minus 2b times x. And finally, the green ones. And the right side is x squared. So the right side is 1 times x squared. There is no x, so that means 0 times x. There is no constant, that means plus 0. So this must be equal to 1. This must be equal to 0. This must be equal to 0. So let's do that. And now it becomes very straightforward. Look at the first one. A becomes what? Negative 1/2. Put it in here, find b. You have a and b, put it in here, find the rest of it. So a quick recap. Find y prime and y double prime, put it into the equation. Collect like terms on the left side and set their coefficients equal accordingly. The coefficient of x squared is minus 2a. The coefficient of x squared is 1. For x is 2a minus 2b. For x is 0. And for a constant is 2a plus b minus 2c. There is no constant. That means the constant is 0. And this is a system of equation. Everybody should have no problem solving.